Gyronics.
Okay, so this problem is quite challenging, but the solution is easy. So the problem states that a lead pencil whose ends are regular hexagons was cut from a cylindrical piece of wood with the least waste. If the original piece was 8 inches long and 1/2 inch in diameter, so find the volume of the pencil. So based on the problem, the pencil was cut from the original piece of wood, which is cylindrical in shape, and it has a diameter of 1/2 inch and a height or the length of 8 inches. Okay, so this is the original piece, and the pencil, which is hexagon, and its cross-sectional area was cut from this wood with the least waste. So to maximize the area, the vertices of the hexagon must touch with the cylindrical or the circular section of the cylinder. So from this cylindrical piece of wood, a pencil was cut using this hexagonal shape. Okay, so of course some of the materials will be wasted. And the problem asks us to calculate for this volume of the pencil. First, we need the area of the base, which is the hexagon. And this is the value we derive from the given figure. We have from vertex to vertex, we have 1/2 inch. So the first step is to draw a triangle. And this is actually from center of the hexagon, perpendicular to the side of the hexagon. We'll be needing this one to the formula of the area of the polygon later. Okay, so we'll explain it later. So we need to calculate for this value theta given by this equation. Theta equals 360 degrees divided by 2n. N is the number of sides of the polygon. And since this is hexagon, the number of sides is 6. So theta is equivalent to 360 degrees divided by 2 times 6. And that will give us 30 degrees. So we have now the value of theta, which is 30 degrees. And the next value we will calculate is this A. This is called the apothem of the polygon. So to calculate for A, we need actually the value or the length of this hypotenuse. Okay, we need first to analyze this hexagon. So if this is 1/2 inch, this one from vertex to vertex, which means this hypotenuse from center to vertex is half of that. Okay, so again from here vertex to vertex 1/2, then from center to vertex is half. So 1/2 divided by 2 is 1/4. Okay, so if this is 1/4, then also from center to vertex is also 1/4, which is the hypotenuse of the right triangle. Now we can solve for A. We don't need that length anymore, the 1/2 inch. So let's focus on this right triangle. So we have theta is 30 degrees, hypotenuse is 1/4 inch, and A is the adjacent to the theta. We can use the trigonometric function cosine. So cosine theta is adjacent over hypotenuse. So cosine 30 degrees, which is the theta, is equivalent to A, which is unknown, and the hypotenuse is 1/4. Then we can cross multiply that hypotenuse, and that will give us A equals 1/4 cosine 30 degrees. You can use your calculator. So A is equivalent to square root of 3 over 8 inch. I will leave this in fractional form to minimize the error in the final answer. Okay, so we have now the value of A. And next is we will calculate for the value B. So B is the opposite, and that is the trigonometric function sine. So sine theta is opposite of hypotenuse. Of course, theta is 30 degrees. So equals to B over 1/4. So the same process, we can cross multiply that hypotenuse to the sine theta, and that will give us B equals 1/4 times sine 30 degrees. Sine 30 degrees is 0.5. So half of 1/4 is 1/8. Or you can use your calculator. Actually, the purpose of this B, which is 1/8, is to find the length of the side, okay, of the hexagon for the calculation of the perimeter. So if this is 1/8, the half, meaning the overall length is twice of that. So 1/8 times 2 is 1/4, which means that is the length of the side of this hexagon. Okay, so actually we don't need that B. We are aiming for the side of the hexagon for the calculation of perimeter. So perimeter is equals to n times s. N is number of sides and s is the length of each side. So since this is hexagon, the number of sides is 6. So we can plug in that values. P equals to 6 times 1/4. And that will give us 3/2 inches. Okay, so the next step is to calculate for the area of regular polygon. So the reason we have those values because we have this equation, general equation for the area of the regular polygon. A equals 1/2 times A times P. So where A is the apothem and P is the perimeter. So this is the polygon we have, the hexagon, and we already calculated the apothem, which is square root of 3/8, and the perimeter is 3/2. Okay, so we plug in the value. A equals 1/2 times square root of 3/8, which is the apothem, times P, the perimeter, which is 3/2. So the area of this given hexagon is 3 square root of 3/32 square inches. So again, I will leave this as fractional form to minimize the error in the final answer. Okay, now so we can calculate for the volume of the solid. So we have here an example of a prism, and to calculate for this volume, we have this general equation. Volume equals base times height. So this is the base and this is the height of the prism. Another formula is we have K times E. So the right section in the lateral edge. But we'll be using the base times height since the given problem does not have a slant edge. Okay, so we'll be using this one, the area of base times height. Okay, so this is the given solid in the problem. So we have the height of 8 inches and we already calculated the area of the base. So this is the area of the hexagon and we can plug in its values now. So we have volume V equals the area of base, which is the 3 square root of 3/32 times the height, which is 8 inches, and that will give us 1.3 cubic inches. So this is the final answer, and this is the volume of the pencil. Okay, so this is the solution for this given problem, and see you in the next exercise.